This is problem 23 from chapter 15 from the textbook Stats Modeling the World, and the authors are BVD. So here we're back to this problem, this real estate problem, where we're looking at homes for sale, and some have garages and some have swimming pools. So let's just take some notes here. So the probability that a home has a garage, the probability of a garage is 0.64, and the probability of a swimming pool was 0.21, and the probability of both a garage and a swimming pool was 0.17. So if we modeled this with a Venn diagram, sorry for the wobbly rectangle, that is pretty bad, isn't it? Can't live with it. Okay, here we go. So try to do it like that. It's clearly not proportional. So if we have garage and we have pool, then in the middle is 0.17. Okay, so we can't count twice, so we have to do 0.64 minus 0.17 is going to be 0.47. So this is 0.47, and then for a swimming pool, I guess I should have used S right there. Let me try it S to be consistent with my notation. So 21 minus 17, that's going to be 0.04. And what's remaining is 0.32. So again, this is called a Venn diagram. Alright, so we've kind of modeled the situation. Let's take a look. If a home for sale has a garage, what's the probability that it has a pool? Okay, so you need to recognize that this is like a conditional probability. So that's what it's saying is what's the probability that a home has a pool, a swimming pool, if, so that's the given, if it has a garage. Like that. Okay, now we just have to remember our formulas for conditional probability. The probability of A given B is equal to the probability of both divided by the probability of the given. It's one way to look at it. So this would be the probability of both a swimming pool and a garage divided by the probability of a garage. Okay, so now we just plug and play. So both would be, that's going to be 0.17, and a probability of a garage, now don't use 0.47, we need to go up to here, 0.64. 0.64. And that's going to be approximately 0.266, or 26.6% of the time. Okay, so that's A. That's problem A. Now, are having a pool and having a garage independent? Well, we have a test now for independence. we can ask, does the probability of A given B equal to the probability of A? If yes, they're independent. If no, then they're not independent. Okay, so let's give it a try. Well, we already have, what's the probability of, I'm going to put a little question mark here, like that. What's the probability of S given G? Is that equal to the probability of S? In other words, does the condition even matter? So over here, we know that this is going to be 0.266. But what's the probability of a swimming pool? Well, probability of a swimming pool is 0.21. Is 0.21. So they don't equal. Right? They don't equal. So therefore, they are not independent. Okay, you can switch it around too. Sometimes it's healthy to do that. Say, what's the probability of a garage given that it's or given they have a swimming pool, and is that the same as the probability of having a garage? So if we looked, probability of a garage was 0.64, and the probability of both divided by the probability of a swimming pool, both again would be 0.17, right? 0.17 divided by 0.21, and I haven't done that, so let's do it real quick. We would say 0.17 divided by 0.21 equals approximately 0.8, what was it? 0.809, so 0.1. So they do not equal. So again, therefore, they are not independent. So you don't have to do both tests, but sometimes it's, if you have the time, do both, go both directions. But pick one, and it doesn't matter which order you choose. Okay, last question. Are having a garage and a pool mutually exclusive? So mutually exclusive also means disjoint. So there we would say, for C, we would say no. Both can happen at the same time. So to speak. Because the probability of a garage and a swimming pool is equal to 0.17, which is not equal to 0. Okay, so remember that mutually exclusive or disjoint events, that would be a situation where all the houses either have a garage or they all have a pool, but they don't have both. Okay, that's how you do this problem. I hope that helps. Good luck.